Now that we know how to multiply polynomials, we are going to look at factoring, which basically takes one single polynomial and breaks it up into a multiplication problem that could be multiplied to get that resulting polynomial. So what we're looking at first is a general type of polynomial, x squared plus bx plus c. Basically, what we're looking for is two numbers, so that when you multiply them together to get c, but they add together to make the value of b. So when you have both signs are the same, polynomial, you have x squared plus bx plus c. You have two separate signs. You have this sign here and you have this sign here. Either one of those two things could be either addition or it could be subtraction. So if we're talking about the last sign to the right, if that sign is positive, that means then that your signs in your binomials are going to be the same. So they're either both going to be plus or they're both going to be minus. If it's minus, that means your signs are different. And then let's look at the first sign. The first sign, if it's positive, means that either both sides are positive or it could mean that the largest factor is positive. It just depends on what your sign was on the first one that we talked about in blue. If it's minus, it could tell you that both signs are minus or that the largest factor is minus. So I know this is rather new and that's a lot to take in, but let's take a look at some examples where hopefully this, and as we progress throughout the factoring unit, will make more sense. So let's take a look at this. So let's say our example is x squared plus 3x plus 2. We know that the first term in each binomial is x. For what we're doing for this particular lesson, it's always then going to be x because we're only looking at the first term always being x squared. And the only way to get x squared is x times x. So this first term in each one of our binomials is always going to be, for right now, x. So then we're looking for two numbers that multiply to give c, but add together to give b. So they have to multiply together to get 2, because that's c, and they have to add together to get 3, because that's b. There's only one way to make 2 with multiplication. That's 1 times 2 or 2 times 1, same thing. So 1 times 2 is 2, so if we add them together, we have to make sure they add to make the b, which our value is 3, and 1 plus 2 is 3. So, again, this sign here tells me, and then this sign tells me that they're both plus. So then these are both plus signs. So then it does not matter where you put the 2 and the 1. One polynomial is x plus 2, and the other is x plus 1. You could have written x plus 1 times x plus 2, and it would have ended up being exactly the same thing. So let's take a look at another example. Again, our first terms are going to be x, because x times x is the only way to get x squared, so now I'm going to have x and x. This symbol tells us that our signs are going to be the same, and then the second symbol tells us that they're both going to be minus. So we know it's going to be x minus something, and oops, that looks like a plus sign. That's really an x, and it's going to be x minus something. Okay, so then I'm looking for two numbers who multiply together to make 12, but they have to add together to make the 7. So my factors of 12, I have three choices. I have 1 times 12, 2 times 6, or 3 times 4. But remember, I'm looking for one that adds to make 7. So that would be my 3 times 4. So then I could say x minus 3 and x minus 4. Again, you could have put x minus 4 first and then x minus 3 second. It does not matter as they're both minus. Looking at this example, x squared plus 8x minus 9. Again, our first terms are always going to be x because that's the only way to make x squared. And then this here tells us that our signs are going to be different. So I'm going to have one that's plus and one that's minus. It wouldn't have mattered if you put the minus with the first x and then the plus with the second x. It doesn't matter because remember, multiplication is commutative. The order in which you do it doesn't matter. So we're looking at here now, because the c is negative, we're looking for two numbers that multiply still to make the 9. So our choices for multiplying to get 9 are either 1 and 9 or 3 and 3. But because it's minus 9, they have to subtract together. And that's kind of a little bit of a tricky thing. It's a little bit different than adding. But that has to subtract to make the b, which is the 8x. So out of 1 and 9 and 3 and 3, the one that subtract to make 8 is the 9 and 1. So I have my factors of 1 and 9. Now, because my signs are different, one's plus and one's minus, it does matter where you put the 1 and where you put the 9. So that's where this second sign comes into play. Remember, it's positive. So it's positive, so that tells me then that my bigger one of the two factors is positive. So out of 1 and 9, my bigger factor is 9, so the plus has to go with the 9, and then the 1 then has to go with the minus. So I would have x plus 9 and x minus 1. Let's look at one more example. So I have x squared minus 7x minus 10. So again, my first term is always going to be x because it's still the only way to get x squared. This tells me that the signs are different, so one's going to be plus, one's going to be minus. And then I need two numbers that multiply together to give me 10. But because it's minus 10, they have to subtract together to give me 7. So my choice is to get 10. There's two of them. It's 1 and 10 and 2 and 5. I want to be able to subtract to get 7 because the 10 is negative. So 10 minus 1 is 9, whereas 5 minus 2 is 3. So there is nothing that subtracts to make 7. So this polynomial would be an example of something that was what we call unfactorable. There's nothing that we can do to get it to be two binomials multiplied together. So our final answer would be this, that it is unfactorable.